Hey guys! Welcome back to my channel. In this video you will learn about green chemistry. Everything that participates in its processes that has less hazardous impacts on our planet. But before that we make sure to subscribe to our channel and turn the notification on, so you don't miss any videos in the future. Green chemistry. In simple, it is defined as sustainable chemistry that designs products and processes that reduce the use or production of hazardous substances. Since the 21st century, green chemistry gained popularity especially due to the increasing climate change and global warming. Green chemistry covers many different areas which are including fuels that generates energy in many forms to power up our society. Every single material involved in making machines or building facilities or small objects for daily usage for different purposes. The substances involved in fertilizers to be applied to crops. The medicine that we is conducted daily and its chemical substances that are involved. The key principles that green chemistry involves is to help improve every covered area to be less hazardous to the environment and its creatures. By using renewable sources and material that are biodegradable. Demanding less energy as well as producing less waste. By applying these principles, chemists can shift the mankind activities shift to sustainable development. What are the principles of green chemistry? As you can see in the diagram, that green chemistry involves the life cycle of every chemical product from the very start of making it and recycling or disposal of that product. By better planning each area shown in the diagram and chemical process involved in making product and looking at these 6 areas, we can hope to have a sustainable environment in the future. The two U.S. Paul Anastasi and John Warner chemists were the two chemists where they developed 12 principles of green chemistry in 1990s. However, keep in mind that the life cycle of a product may not follow or satisfy all these principles, and it has to be decided which aspect is important. The first principle is waste prevention, which stands to first ensuring the product has minimum waste. This principle focuses on prevention instead of cleaning up the waste once it has impacted the environment, and plan to minimize waste at every step. The second principle involves atom economy. This principle focuses on destroying or reducing the waste impacts at molecular level by maximizing the number of atoms from all reagents that are incorporated into final product. The third principle is less hazardous chemical synthesis. This principle involves in designing chemical reactions and synthetic routes to be as safe as possible, and considering that all the hazards of all substances handled during the reaction including. The fourth principle stands for designing safer chemicals. This principle focuses on directly reducing toxicity through molecular design. Throughout the design phase, predict and analyze elements such as physical attributes, toxicity, and environmental fate. The fifth principle. Safer solvents and auxiliaries. This principle focuses on widening the stages of production of product, in which for each stage, select the safest solvent available. Reduce the overall amount of solvents and auxiliary compounds utilized, as they account for a major portion of the total waste generated. The sixth principle. Design for energy efficiency. The first thing this principle focuses on is to select the least energy-intensive chemical path. Second. Avoid heating and cooling, as well as pressured and vacuum situations. For example, the ambient temperature and pressure should be ideal when producing a product. The 7 principles. Use of renewable feedstocks. The main point to focus on is use chemicals derived from renewable and mostly plant-based sources rather than other equivalent compounds derived from petroleum-based sources. The 8th principle. Reduce derivatives. The first focus of this principle is to use of temporary derivatives, such as protective groups, should be kept to a minimum. The second point is to reduce reaction steps, avoid derivatives, resources needed and waste generated. The 9th principle. Catalysis. Firstly, it focuses in reactions, utilize catalytic reagents rather than stoichiometric reagents. Second, it focuses on selecting catalysts to aid in increasing selectivity, minimize waste, reaction times, and energy requirements. The 10th principle. Design for degradation. First, it focuses on creating chemicals that disintegrate and can be simply dumped. Then it focuses on ensuring that neither the compounds nor their degradation products are hazardous, bioaccumulative, or ecologically persistent. The 11th principle. Real-time pollution prevention. This principle focuses on real-time monitoring of chemical reactions to prevent the creation and release of potentially dangerous and polluting chemicals. The 12th principle. Safer chemistry for accident prevention. This is the last principle of green chemistry, which focuses on choose and develop cynical methods that are safer and, as a result, reduce the chance of accidents. The second principle is that to be aware of potential dangers and examine them ahead of time. Is the lesson for today. I hope you have learned something new today with us. Thank you for watching my video.